All right, I've got 1 minute after, and I want to respect all of your time. So let's dive right in. And thank you very much again, everybody, for joining this session. We're super excited you're able to join us today as we talk about Gen AI, specifically how it's impacting financial services, the market, the industry, some of the things we've been working on, a lot of the things that we're seeing out there, and how things might change. So Gen AI is certainly top of mind for a lot of folks right now. Here at ClearObject, we've been digging into it along with Google. We're a Google Cloud partner there, so we've been working closely with them to help folks understand what they should be doing, how they should be doing it, how they should be thinking about it as we go here. So why don't we pop over the next slide? So 13 trillion. So McKinsey did a study and they are saying that there'll be $13 trillion in additional global economic output thanks to AI. That's I can't even wrap my brain around how big a number that is. It's incredible, and people are already seeing benefits from that now. So by 2030, that's how much they'll see, and we are not that far away from 2030 at this point. I'd like to introduce you to Tim. He's our lead data scientist to talk a little bit about exactly what is Gen AI and where it came from.
Awesome, thanks, Todd. Yeah, if you go to the next slide, so I'm just here to talk about what is generative AI, how does it fit into the overall landscape of AI, what's kind of been that recent paradigm shift and why we're hearing so much about it now. So you're probably already familiar, but we've had neural networks for quite some time, since before ChatGPT, right? So we've actually had neural networks since the 1950s. But really, for the longest time, to get better and better at different use cases, we essentially branched out and made a bunch of different types of models, and each one of those models got their own inductive biases and more inductive biases over time. So all an inductive bias really is like a rule introduced to the model to try to approximate human intuition about a use case. So for language, we basically would tell the models to read text from left to right. For vision, we would say the most important context about a pixel is going to be the pixels immediately surrounding that pixel. So for the longest time, to get better and better models, we've tried to think of more and more clever rules, and that resulted in a lot of different model architectures. But more recently, we've had kind of a triple whammy of events that have led to this new craze of generative AI. So the two boring ones, we've had a huge increase in data volume coming from the internet, and our hardware has become way more efficient. So our GPUs and TPUs are just way more efficient. But then the cool thing is 2017 when Google introduced the transformer model architecture. So the interesting thing about this transformer model, it was almost designed more so in terms of hardware efficiency. The thought was this would be a very efficient way to process a lot of data, and let's hope that it can learn things more so than being a clever way of learning things. So what this transformer model did was it basically removed as many inductive biases as it could while still offering like a good computation mechanic. And you can see that on my graph here. We've kind of gone from needing a bunch of rules that we introduced to the models to now just needing more and more data and better hardware. So this transformer model is more of a generic computation mechanic. It's very efficient because it processes things in parallel, and that all happens in what we call the self-attention portion of the network. So if we go to the next slide, I'll talk about self-attention a bit. So again, the key idea of the self-attention, the major benefit process-wise is just that rather than reading things sequentially, which is slow, you just read everything in parallel. But that offers interesting capabilities in terms of learning. So really the main idea of self-attention is that every data point can look at every other data point, no matter where it is in the context. So again, in the past, for language, you'd have to read from left to right. For vision, each data point is only really concerned about the ones immediately surrounding it. So now we basically just say all data can look at each other the whole time. That has some interesting results. So the top middle example, if you were to use a naive sequential model to translate from German to English, you might get something nonsensical. Can you help the sentence to translate? But if you use a self-attention network where you see kind of this crisscrossing of the arrows, the data is looking where it needs to go to put the right stuff where it needs to go. You get a good output. Can you help me to translate this sentence? The even cooler part, since this is such like a generic computation mechanic, you can apply the same idea to a lot of different use cases. So in the past, again, we had different models for vision and another model for language and whatnot. But now we can basically do a very similar thing with vision problems. So we can patch up an image into a bunch of different chunks. You can think of those chunks as words and the full image as a paragraph. And now we're just passing it through the same model architecture that we passed the words through. So this is pretty interesting because now you can look at this example on the right with GPT-4, both understanding a user question and what's happening in an image that the user input. And the model's able to respond and say, the funny thing about this image is that you've plugged a VGA cable into an iPhone. So yeah, again, the key thing here, this transformer architecture is kind of taking over a lot of different use cases, and it's all about this generic parallel processing mechanic that allows for some really impressive learning. If we go to the next slide, I just want to break down the transformer model a little bit more. So there's really two halves to it. There's the encoder half and the decoder half. The encoder creates basically a fingerprint of data, just tries to distill it down, and you can use that distillation to do things like sentiment analysis, classification, anything like that. The decoder half is what you use to generate new data. So lots of chatbots are actually like decoder-only portions of these transformer models. If you combine both of those together in the same thing, you can do things like full machine translation, French to English. So again, this is just another neural network. You can interact with this in the same way that every other neural network has been interacted with before, where you just take a large training set and you train on that data over time and try to tune the model weights to perform well at a certain use case. But what's actually really unique about these models is an emergent capability we call in-context learning. If you go to the next slide, the idea of in-context learning is that these transformer models can basically learn in just the forward pass, so just at prediction time, with no back propagation or gradient descent to tune the model weights. So yeah, I'll just restate, the model can learn just at prediction time. It's really wild and a new capability. So I have a couple examples to kind of show what that means. For the encoder half of the model at the top, so you can pass a bunch of images through the encoder and get those kind of fingerprint representations, these vector embeddings of all these different images. And then you can just do very simple math, think like Pythagorean's theorem to calculate the distances between these vector representations of these images. And so you can start to cluster. I basically scraped the whole Met Museum of Art website for all their paintings. And you can see these clusters here taking what looks like similar paintings next to each other. So again, with no training on what these images actually look like or anything, it's able to generate a good representation of these images. Even cooler example on the bottom. So again, the decoder portion of the model is what generates new text. What I did was I made a prompt on the left that basically says, read the example inputs and outputs and try to translate the final sentence. The catch here is that in green, my outputs it's an entirely fake and random language that every time I generate this prompt, it's a newly generated language. There's no chance the model could have ever seen these words before, but it's able just within this prompt to do this in-context learning, understand what words correlate to what from my fake language to English, generate the correct output. So you can either trust me or squint your eyes and try to see, but that output is correct. So again, the crazy thing here is this model has learned this language just from one simple chat paragraph that I ever sent to it without ever having to train on new data or anything. So these are fun examples, but if you go to the next slide, I have a more business relevant example. So lots of businesses have huge corpuses of data on their SharePoint or anywhere else where there's lots of documents, and everyone just wants a quick way to like query those documents, get an answer without having to dig through a ton. So you can use this encoder decoder approach where maybe you ask a question, you can pass that question through an encoder and get a vector representation of it. You can also pass all your documents through an encoder as well. Then you're doing the same thing I did with the images, but now with like relevant textual information. So basically ask a question, find relevant chunks of text to that question. Then you do some prompt engineering and you say, use the context below to answer this question. You paste in the relevant context, and then you ask your question. Then you just pass it through the decoder. So in the same way that the model is able to learn my fake language, it can learn the relevant information from the text that I've pasted in, kind of generate an answer. Even cooler, because you know where you got that information from, you not only get an answer, you get like a reference back to the PDF and the page where that information came from. So the key thing I just want to point out here with these new generative models, what makes interacting with these so different is this in-context learning capability. It allows for very fast attempts at new POCs or different ideas because often, I mean, you can, but you don't often need to actually train the model on anything or introduce any of your proprietary data to the model for it to be able to still answer questions about those data you give it the correct context for it to do the same context learning. So there's a lot of implications for this, different use cases in business and whatnot. I'll leave it to Jason to handle those, but before that, I believe Todd has a couple more poll questions for us.
And with that, let's turn it over to Jason. He's our Gen AI guru, product manager here. Take it away, Jason.
All right, thank you, Todd. Yeah, and thanks, Tim, for giving us an overview on kind of the background where Gen AI has come from, some of the academic side of how it works. I do just want to talk a little bit about adopting Gen AI and give you an idea of like what type of use cases might be useful in financial services and really for any industry. And then we'll also dive in a little bit onto some specific use cases in financial services that you might find useful. If you go to the next slide. First thing I want to cover really quick is what is unique about using Gen AI models. If you have a data science team, what's kind of different from what you've done in the past with traditional models. So that top flow there shows what does traditional machine learning look like with your data science team in the past. Most likely you've spent a lot of time gathering data, cleaning it, labeling it in preparation to do the modeling. Then you have to decide what type of model am I going to use, actually do the training to produce a model before you deploy it and can start using it. So a little bit different in generative AI. So you've probably heard of large language models. And typically these models are trained on very large data sets. And that's typically done not by your data science team, but a foundation model provider instead. So you can see there kind of the data is really being gathered by the AI research team. And then they're going to provide a model that they have built via an API. And that is the point at which your data science team starts picking up and using that model. And so what really comes into play, which is kind of interesting, is this whole providing context prompt. And that gets back to kind of what Tim was talking about, where in just kind of a forward path, we're not actually going back and retraining the model at all. We can just provide context of new situations that the model can pick up without retraining and start using that in the form of context prompt. And then from there, you can start using those models. So it's a little bit different path than what we've seen in the past, where a data science team is building the whole model. In the future here, you're going to kind of pick up after a data science research team has already built that model for you. Okay, let's go to the next slide. Okay, so what are some things that Gen AI models are good at? So kind of three key areas here to note. It's kind of in the name, but it's good at generating new content. This is different in the past where a traditional model, you're trying to predict something based on a training set. Here you're using the training set to get an idea of like new kinds of things you could make. And it is worth noting this could be a wide variety of data sets, images. It could be text. It could be other types of unstructured data as well. And also what's kind of interesting is they're good at a large number of tasks. So in a traditional model, you're good at maybe doing one thing. In these models, they can actually learn many different capabilities. And that kind of gets back to the inductive biases that Tim was talking about. And the last thing to note is you can tailor these models for specific use cases using the context prompting that we had discussed earlier, as well as using some advanced search capabilities as well. Okay, so let's move on and look at some examples in financial services that we have been talking about. So the first thing, this is going to be common in a lot of industries, but it's just like making large data sets easier to understand. So you may have a financial research agent, which helps you investigate company financial data very quickly. Another use case would just be summarizing reports that you have coming in. So if you have new 10Ks or something coming in that you would like to get a summary really quick, Gen AI is good at pulling out key pieces of info and giving that back to you really quick. Go to the next slide. Content generation. So this is another great use case for Gen AI. In financial services, you could actually automatically generate, say, new statements of work. You could enter information about someone and their background and automatically generate a loan document, for instance. And you could also do things like producing standardized reports for your company. So you can make a template based on previous reports you've created, pulling in information to different sections, and Gen AI can be very helpful at pulling in especially the text summary data within those reports. And then finally, automation use cases. And this is another area that a lot of people will be starting, especially if I go to that second bullet, customer service agents. Very common use case, say for banking firms of, hey, I want to check in on my bills, or I want to check in my account balance. Gen AI models can make that a more conversational experience. And another specific use case to note is it actually can be very good at detecting things like compliance risks. You can tell the model this is what a potentially fraudulent activity might look like. And then as new documents come in that are relevant, it can try to look for that pattern of fraudulent activity and flag that for you to review. Okay, can we move on to the next slide? So it is worth noting there are definitely some challenges with adopting Gen AI right now. A lot of these models are very new, and so we're still kind of working through the kinks of exactly how it will work. You may have seen where Gen AI models can sometimes hallucinate. This can be a big deal in financial services where you need actual data that is always accurate. You can help with this by what Tim talked about, where you can reference back to the data source where these results came from. That can help. And another thing to note too is large language models especially are very good at dealing with text data, but how to incorporate tabular data from financial systems is a bit more difficult. You can look at things like lang chain models where you are chaining large language models together to say produce SQL statements that then goes to an actual data source, return data that way. But these are more complex examples and it can take some more time to work through that. So just wanted to highlight some of these challenges as you try to incorporate or find POCs for where to get started. All right, let's go to the next slide. Just wanted to finalize here. This is a bit more of a broken out example of how could you tailor Gen AI for your use case. Just wanted to highlight again, you have two main options. One option, which is the less popular option at the moment from what we're seeing, it's actually training a tuning layer on top of a foundation model. So it's actually taking neural network and adding your own neural network layer to that base model and tuning the weights for that layer. The other option, though, is to take your data and by using that kind of fingerprint embedding approach that Tim talked about, incorporate your data in that way via search as part of your context prompt when you interact with that large language model. Okay, and if we could move on, just want to cover real quick some of the high-level platforms that we're seeing in the Gen AI space. As Todd mentioned at the beginning, we are a Google Cloud platform. We are leaning in with them. We do feel that they have some good benefits in terms of security, the options of models they have, just the performance of those models, as well as the careful nature of how they're putting guardrails around their model. But there are a number of generative AI platforms we work with. OpenAI obviously kind of blew up everything at the end of last year with ChatGPT and making this such a popular space. And then there are some other players as well to note here. So we just wanted to note there are a number of platforms that you could be using. We work with many, but yeah, Google Cloud and OpenAI have kind of like opened the doors first. Okay.
All right, thank you, Jason. Yeah, let me say a little bit here about some things that ClearObject has to offer. And while I do that, there is a QA section over on your right near the poll area. If you have any specific questions for Tim, Jason, even for myself, please pop them in there and we'll do our best to get to them in the few remaining minutes. But some of the things that we've been doing with a lot of companies, especially in financial services, is doing these generative AI discovery workshops, which are fantastic. If you know you should be doing something here, you're not sure what the ROI is, what exactly you should focus on, how you should prioritize your efforts. Again, we've developed these in partnership with Google and working together to make sure that folks are putting their resources and their efforts in the right area. And from there, we're working with folks to help them take that to a proof of concept, to really get it out there and test it with real customers, real benefit, to make sure it's doing what we think it will do, folks that are enjoying it there as well. Then ongoing services and other data science development type things. So we are here to help you think through these things. We are here to help you develop them as needed and get them out, launched, and supported. And we've been doing actually quite a bit of work in the financial services sector recently, especially around what Jason mentioned earlier with the financial research agents and some of the customer service agents as well, which is great. So if you do have any questions, you can pop them in there. I do have one, Jason. You talked about the security and thing. Are there any unique like security concerns or things, especially in the financial services industry, that and benefits of using AI and how they should think about approaching that?
Sure, I can touch on that really quick. I will note one thing that is worthwhile to just be aware of is the difference between consumer-facing Gen AI tools and enterprise-facing tools. So the first thing I would note is like if you are using ChatGPT, just be aware of what the terms and conditions are for tools like that, because a lot of them do say they can use your data and what you enter into there to retrain their model. Now on the enterprise side, it's a very different situation for really all these platforms in the enterprise cloud space. So for those tools, typically the terms and conditions are such that the models are fairly frozen that you interact with. The data that you are sending to those models to interact with that API, they will not use your data at all based on those terms and conditions. And so just be aware, in the enterprise space, there is a lot of work going on to say, how do we make sure that all of your data is secured in your cloud environment and that it's not intermixed with anyone else's, and the models are not going to use that data to address, IP concerns. So I think that is definitely something to note. And there is a lot of work going on with the major cloud providers like Azure with OpenAI and Google Cloud and AWS to make sure that all of that data is fairly isolated and secure within your tenant when you interact with these models.
So I'm going to ask a follow-up question on that one, Jason. When you say that the data for your enterprise solution is frozen in time, how often then do we need to update that and pull new data in to keep it fresh and relevant?
So just to note there, the model itself is what will be somewhat frozen. Now, over time, those models will be updated by the AI provider. But as far as like how do you incorporate your data set, that gets back to the tailoring. And so that's basically where you will want to smartly prompt the model with your data, and you can continually ingest new data into your embeddings database to make sure you have very current data. And so that all has to do with the smart prompting and making sure you're embedding data on an ongoing basis. So the model is frozen, but the way you provide context, that data set and the context can be continually updated.
Great. Thank you. And we are at 10:30. We wanted to get you guys out of here in half an hour. So thank you very much, everyone, for joining us today. Thank you, Tim and Jason, for sharing your insights on this. We are happy to continue the conversation. If you have any questions or want to talk to somebody here, please reach out to us with ClearObject. You can find us on LinkedIn, our website, clearobject.com. And we hope to chat with you all soon. Thank you very much and have a great rest of your day.